thanks for being with us. It's a great pleasure to host everybody. This was the most diverse conference ever. We had people from all around the globe, and it was really cool. We added more tracks. We had a mini kind of blockchain engineering track. We had data track basically fused into this. So we had a lot of really cool topics, but we never did anything like this panel. So this is really new to us, right? So we basically go very deep and very broad, right? So the topic of this panel is Cloud Edge and Silver Lining, and the idea is that as a community we do a lot of traditional cloud computing. So we kind of know how to spin up a big AWS cluster and kind of launch a bunch of jobs and try to SSH into them and see what's going on. Or like try to figure out what's going on in some web browser. And so this is kind of cloud computing. But suddenly we're in the world where nothing is certain, right? So suddenly we have blockchain and we have edge, and all these words are showing up, and we need to figure out what to do with them, right? So I think like as a community we're more familiar with traditional kind of single processor or multi-processor in a box, or multi-computer data center. So DCOS is kind of as high as we go on the abstraction level, right? But suddenly we get a lot of new things, and what got me interested in this, I ran an engineering enterprise blockchain conference called Rethink Trust, where we completely banned the word ICO. It was completely about engineering side of this. And turns out there is a whole bunch of companies which basically try to build this distributed consensus systems for trade, for kind of energy communication, for like any kind of enterprise application where there needs to be an agreement. And turns out, agreement can come slower. Sometimes, some kind of things cannot show up. And so there is even talk now that eventual consistency is not important. There's, like in the world of tomorrow, there will be no eventual consistency of everything. Forget about it, right? So basically there will be islands of disconnected consensus. So all of this is very cool, and so we have really good representation of folks on the panel coming from different worlds. So I'll just let you guys introduce each other, maybe like for 1-2 minutes, kind of tell us your take on this future where cloud and edge and IoT are all interconnected. Where are we going, and kind of where you want to be, where you're driving this, and then we'll pick up on the themes and have a conversation. In about maybe like 20 minutes before the end, we'll open the mic to the audience, so prepare your questions, and really feel free to talk among each other. It's not just me asking questions.
Cool. I think this is the first time I'm going to take this off. I wanted an excuse to look really cyberpunk, but in San Francisco, thankfully, provided that weather, but Twitter just has slightly good air, relatively speaking. This is the first time the work that I do has been called traditional, so thank you. I do mostly traditional data parallel systems. But I think certainly edge computing is very important, and the idea of always bringing everything back to cluster to compute everything is perhaps not the future. Very inconvenient for someone who sells clusters, but that's okay. You can learn new things and build new tools for people as well. I'm really jet lagged. I was in Madrid yesterday. I think that was yesterday. So I don't remember everything else you told us to do, but I can answer direct questions. So I'll just pass this on to you.
All right. Hello, everyone. My name is Roman, and I actually, it's funny because I think I'm trying to now escape this traditional because you guys are traditional now. So this whole big data thing. So 2012, Edge is coming. So that's what I'm doing. I actually have a company that I'm one of the co-founders of. That we're doing a next generation edge computing platform at. I also do a lot of the open source, so I'm actually a working billboard of all of the Apache projects. So if you want to know what Apache does in terms of projects, just walk up to me and look at this. So there's Hadoop, there's a couple of other things. So I also happen to be on the board of directors of Apache Foundation, Apache Software Foundation, and do a lot of things there. And I used to do big data, a lot of it. So I used to be at Yahoo and Cloudera, but like I said, it's so 2012 now.
All right. Hello, everyone. My name is Haoyuan Li. People also call me HY. I'm the founder and CEO of Alluxio. So just a little bit about ourselves. So we believe the future about the data is a data-driven world. And in the data-driven world, you have data-driven applications like machine learning, AI, analytics, etc. And also in the data-driven world, you have a lot of data storage, persistent storage, like cloud storage, multi-cloud storage, on-premise storage, file system, object store, etc. So we believe if you go into the future, you need to have a data platform. And our technology essentially is open source technology. It's between applications and persistent storage. And essentially, we aggregate and virtualize all the data from storage world and present a global namespace and unified APIs to the data-driven applications. So why is it related to the edge? I mean, first of all, you all know it's super relevant to the cloud. And in fact, many people run us in a multi-cloud or a hybrid cloud environment. And also, we have people running us in the edge environment today as well, which I'm happy to introduce later on. Thank you.
Hey guys, I'm Wyatt. I'm the CTO of Constellation Labs. I'm building a new kind of blockchain called a DAG, which is focused on a lot of this stuff. And we're taking application support a little bit differently than how we're doing things in this space, which we think is kind of applicable to this space, which maybe we'll talk about today.
Cool, thank you guys. So I will have maybe kind of one, first simple question, right? So we see kind of with, I think the rise of blockchain brought with it very interesting set of open source things like EOS. So Roman explained to me a lot of EOS. I looked at it and there is a lot of open source activity. People basically want to build the distributed applications. Can you summarize for us, kind of what do you think are the main distinction, right, between dApps and kind of traditional apps, and what does it mean? Like, can these things coexist, for instance? Like, where do we put all the data? Because, like, we cannot put much data on the blockchain. It's not very capable. What's your thinking about where this is going? If dApps are going to take on, how are they going to coexist with the cloud? Are they going to supersede the cloud, replace it? Are we going to see them back to back? What do you think is going to happen?
Oh, sure. Sure. Well, traditionally, people tend to use this concept called like a smart contract. But I think that especially as we're moving towards gathering a lot of data from a bunch of different sensors like the edge, as I think we're calling it, I think there's a new opportunity to sort of use consensus as a way to validate data in general, and sort of actually thinking about am I passing around transactions or am I passing around bits of data that I want to get validated, and we think that that's our approach.
There are different technologies to build the data stores for security, for consistency, for scalability, etc. And based on what we're seeing, we talk to many enterprise customers, and most enterprise people today, no matter what type of technology they're using, they ended up today in a multi-storage environment. For example, they typically have lots of on-premise storage. Could it be HDFS, ECS, Echelon, like GPFS, many, right? And they ended up with this very messy data environment, data silos, people call that, and they have many data duplication. So then the cloud came. With the emerging of the cloud from the small company perspective, like startups, mid-sized company, they may use more of the cloud for storage. But what we're seeing from the big company perspective, in the end of the day, I think people realize and they understand that data is actually the most valuable asset in the company today, and particularly moving forward with the more applications are being innovated. So because of that, actually what we're seeing is that these companies, they don't actually put data in the cloud. So they still put the data in the on-prem environment. And with this, they actually use the cloud as the bursty computation compute environment. Say they have several thousand machines in the on-premise environment. They want to do a big model training. So they want to spawn several more thousand machines. So they do that in the cloud. That's the way we see that. And we believe for foreseeable future, like say 5 years from now, probably this will not change. Like this big enterprise, they will still host their data on premise with various technologies, blockchain or the previous protocols, and they leverage the cloud for the bursty workload. But this only applies to the enterprise.
Right, so I'll just add a couple of thoughts because I think my colleagues are exactly right on some of those points. But the way I look at it is our whole industry is going through phase shifts all the time, right? It's between distributed and decentralized all the time. So I think we've just passed the distributed phase and sort of went into this whole centralization one, right? The big cloud in the sky is kind of like a mainframe, right? So it's about overdue that we actually go yet another step and do the full-on decentralization, which then brings us to blockchain, right? It's like if you do full-on decentralization, like how does your database look? Well, it looks kind of like a blockchain. And how does your stored procedure look? Well, it kind of looks like a smart contract. And then some of the learnings from the distributed systems is like what's interesting in the distributed system? Actually, two things only: storage and scheduling, right? And then you basically do scheduling through something like EOS, or there's other blockchain examples like that, and you do your storage somehow. I don't know. I mean, if you have answers to that, let me know. Storage is really tricky.
Yeah, if you want to replace HDFS with the blockchain, you have a really sad time or a lot of venture capital money, possibly both. Venture capital money can fix some sad times, but not all. Yeah, I mean, I think our industry is one of fashions and trends, and certainly we have a new fashion and trend, and it'll be a party. We'll all have fun. I don't know. I don't really have anything else to add, except this is going to really suck to write the code to do. Oh, God. Debugging is the worst. It's okay. They pay us. I hope.
So maybe, I'll kind of maybe make it more concrete. So at Rethink Trust, we had a company, Dianetics, which basically wants to be the first genomics on the blockchain. And so they spend a lot of time compressing DNA, right? And they put some of it on the blockchain, but obviously the problem with that is, if you lose it once, right? You lose your genome once, you leak it, that's it. It's out there. And it's a big problem. So basically, there's been a lot of thinking, right? Like, let's say we have something like your genomic sequence. So we kind of in our traditional now kind of cloud world, we can put it into Spark, right? So this is one of the top things. We want genomicists to do with Spark because they're still at the Perl stage, right? Like if you look at bioinformatics, it's traditionally like 5 years behind what we're doing here. So it's like they're still very excited about Perl. So eventually the news will reach, that now it's the cluster.
Perl is cool, man. Come on.
I agree. No, I love Perl, right? Like but kind of just to kind of show the timeline, right? So I've been at the Bioinformatics Institute at Penn and asked who is using Spark. Nobody uses Spark. Everybody heard about it, right? So that's kind of where we are. So we want people to put DNA into Spark, and the cutting edge folks do that. So we have startups doing that, and they can cure cancer. So this is kind of clear, hopefully. But the question goes away. We don't discuss the question what happens, like where do they store this DNA, because we kind of assume that there's a traditional security model because like it's on a secure disk, it's under lock and key, it's encrypted, and we kind of assume it's okay. But although we know companies lose data all the time, and all the cloud companies lose data, right? So there are two questions here, right? So first question, can we achieve the compression? What do we do with this kind of data? So one idea is that put it in a sidecar in the cloud, put a pointer on the blockchain, and have some provenance discussion. Who can see things in the cloud? Now you can look them from both places, right? And so the other approach is to put everything into the blockchain. Then there is a question of what is, it persists there. What if there is an error, right? And so we kind of have this new kind of distributed system, right? But it's permissioned better, right? It's kind of we can reason about who can read this. So what do you think of the implication of this? I wonder, like, if you kind of have ideas about that.
I thought. This is being recorded, isn't it? Why, for fudge's sakes, do they want to put DNA information in the blockchain?
I think the reasoning is that now you have granular control over who can basically you can say now the pharma company can see it if you allow it, and basically you can granularly open it to the parties, to the nodes. Like there will be a node to which it will go if you have a smart contract of some sort or something like this, right? So basically you will programmatically define very fine-grained model who can see what, and there will be a trail of access, right? So if you grant access to your physician or to your like you're in a clinical trial, right? So I think this is what they want. They want like fine-grained control, and then let's say I think another use case is let's say somebody's developing experimental cancer treatment, and they need to run on a bunch of cancer data. So in ideal world, you will give this research organization permission to mine your data in a specific way, which may be anonymized, and so basically you will opt into some kind of data mining through that instead of just uploading your data and hoping people will follow some rules.
Sure, I don't see how the blockchain fixes that problem, though. Maybe I'm just not cool enough. I mean, personally, if that was my worries, I would look more at public key cryptography, just store my data and then control who I give my keys to, rather than putting it in the blockchain. I mean, if I needed to raise money in San Francisco, yeah, sure, I'd definitely put that shit in the blockchain. But I wouldn't do anything with the blockchain. Just store a copy of my data there for venture capital money. I don't know. Maybe I'm cynical. But I think Spotify has a really interesting thing where they talk about their solution to GDPR compliance and how they essentially were looking at the possibility of, and this is me talking about another company's technology, so of course there will be some mistakes in my recollection of it, but essentially rather than trying to propagate their deletes because they don't trust themselves necessarily to propagate their deletes in a timely manner, they just revoke the keys, and the keys are no longer able to access the data. And so the data itself is still there, but the keys are gone. And eventually they'll get around to cleaning up the data as they're required to. But in the immediate term, the key server will no longer grant a valid key to look at that data. And I think that's maybe a much more reasonable approach, but maybe I'm cynical. What do y'all think?
I really agree. I just want to say, I think that happens a lot, and it kind of sucks. You know what I mean? It's like, let's just put everything on the blockchain. Let's put your sandwich on the blockchain. Let's make your own sandwich. Blockchain sandwich. Yeah. Anyway. Yeah, so just barring that, sorry, but all use cases aside, I mean, yeah, obviously also the GDPR, kind of HIPAA and PIPA issue, I think is really the one that people do touch on, but I think traditional methods are really just what you want, and for most cases, really, I think it's, you just gotta really just realize that this is almost kind of, I mean, it's not necessarily just about validating transactions, it could be other kinds of data, you know what I mean? So this approach of really thinking about stuff in terms of let me just use it to I'll put this thing on the blockchain because I can think of it as some new way to be a database. It's there are different databases for certain use cases and certain tools, you know what I mean? And it's all really just about getting that truth, that validity of some kind of data set, you know?
Yeah, I guess my only comment would be, speaking of cryptography, I think we actually saw a very interesting company at the Rethink Trust conference. I believe they're basically research, out of Russia, someplace, and they came up with this really cool way of essentially re-encrypting to a different key without actually decrypting. So, they have a full encryption that is possible without ever revealing, sort of the source material. So then you can store sort of the original copy in, big cloud in the sky blockchain like you don't care. And then you basically essentially issue these, one-time operational keys that would re-encrypt it to a particular user, and, that's just fine. So I would look into things like that, maybe, because just blockchain by itself is probably not enough to solve some of those use cases.
So blockchain is a trend, and it's a sort of new technology. From the research community angle, lots of paper has been published a long time ago. And for the particular use case we mentioned here, actually the existing technology can solve it as well. And we have seen some of the users like solving a similar problem. So, but from the future angle, it's like years ago, people talk about go cloud, right? So that was years ago. And the first wave of going cloud, like we talked, I just came back from New York this week. I talked to quite a few CTOs from some of the largest banks in the country. So the first wave of going to the cloud, it was from their word, it's a disaster. So in the sense of, it's many conversation, but in the end, the value was not really realized. There were some realized, but in the end of the day, it's hard to say anything will all go certain things. And that's the reason, like at the beginning, people talk about the cloud, and today people talk about the hybrid cloud. It's a similar thing again. It's I believe in the end of the day, things will end up somewhere in the middle. Like it's not necessary to be all like one thing and one technology. It just never saw the world like that, and probably at the foreseeable future it won't be like that. That's just my view.
Actually, just to quickly comment on that, if I may, I think it's actually really easy to be cynical, so I cannot believe that I'm playing the role of the blockchain guy. I guess that you must be saying this. But I think it's actually really easy to be cynical, and here's why, right? Because like every new platform that comes is actually typically really, really, really bad and really much worse than anything else that's already available on the market. So it actually takes a lot of insight and luck, frankly, to realize, because 99% of that is just crap. Like, I would absolutely agree with that. But there is that 1% that is still worse than everything else, and yet will be the next big thing, right? It's like, is it blockchain? I don't know. But I also wouldn't like to succumb to this temptation to say, like, well, yeah, looking at all the prior experiences, we can use stuff that's currently available. Sure, but, maybe we're missing something here.
Maybe. Maybe I would ask you, what do you think is the killer app for blockchain, maybe connected with the edge? Like, what is the app that will clearly and demonstrably run on blockchain, and it's hard to think how else to do it? Can anybody think of that?
I think it could have been your app, man. You never know. Like, we're all just trying. I don't know. Apps are interesting. It's we're very tied to this rudimentarily, like tied to the smart contract idea. But like, what is it really about under the hood? You know what I mean? Like, have you guys ever really thought about like, oh, someone's gonna like have the ability to like maybe drive a car at some paywall and it gets paid? And I've seen these demos before, but like what is it? It like goes and like sends this little transaction to a thing and it waits. And it's like, okay, like there's totally a way that we could actually integrate this notion of cryptographic security, or like just getting consensus to like, solve this problem for you, like figure out if your data is actually factual, which is a real problem, it's garbage in, garbage out for a lot of people's uses. So yeah, we think it's gonna be like that.
Honestly, I think it's trust. That's why I think that conference was actually really telling. If there's anything really exciting to me about the blockchain and edge at the same time, it's actually thinking about the trust implications, right? Because for both, edge, right? Let's take that one as a first example. Like, we're actually so used by now, for a data center to basically have, all the security elements that just don't exist on the edge, right? Well, for one, there's typically a guy with a machine gun in front of a data center, right? So you have a physical perimeter security. Then networking-wise, well, you typically have the big Cisco firewall in front of your data center. You have that network security. Now, again, even those get penetrated from time to time, but at least, you have those. On the edge, when even in the industrial setting, right? It's like Iranian, nuclear fusion example, where they get hacked by Stuxnet. Like on the edge, anybody can walk up to your server and just plug a USB stick in, right? So I think, this implication of trust is very central to the success of the edge. And I think, again, that's why it's sort of like very tempting for me to sort of keep looking at the blockchain, because if there is a single feature that blockchain has that not really has been sort of seen in that sense before, it's managing trust in a really very weird sort of multi-party co-opetition environment, right? Where it's not like we're all adversarial, but it's not like we're all friends either. So if we can kind of like, match the two together, then maybe we actually can sort of really build this cyber-physical trust, where you can actually get the data point and then trust that data point, whether it came from a cyber system or a physical system.
So I spend a lot of time on airplanes because that's my life. And there's a really depressing statistic about the percentage of fake airplane components in circulation. They even found fake airplane components in circulation on whatever the president's airplane's called, which is like interesting. You would assume that there's like higher quality standards associated there. And I think certainly trust is one of the things where you have a bunch of different sort of independent players who don't necessarily like to talk to each other, but if we can convince them with the magic of blockchain that they should talk to each other because it's the future, regardless of whether or not it is the future, that would be kind of cool. Because it'd be really nice to fly on an airplane that wasn't made of counterfeit parts. I don't know. I mean, the counterfeit parts are really well done, so like, it's probably okay, but I still would feel more comfortable flying on non-counterfeit parts, just personally. So if we can fix that problem with the blockchain, I'd, write some shitty Scala code to help. Yeah, actually, so if you're interested in airplane crashes, there's this wonderful show. Oh, no, actually, so sometimes they don't put it in the like normal in-flight programming, but if you're on one of those airplanes with DirecTV, they don't blacklist it, and so, and it's like one of those like National Geographic productions, so sometimes you'll just be like, oh yeah, I can watch a show about airplane crashes on my airplane. And also, pro tip, I found out talking to people about airplane crashes, and the airplane makes them uncomfortable. Even if they work for one of the companies which made a faulty part, which causes an airplane to crash, that doesn't make it better. But yeah, anyways, the program is called Mayday. Really good program. I encourage you to check it out. Yeah, so, and there is an episode about the faulty parts that caused one of the planes to crash. It's really exciting. But like, somehow most of the counterfeit parts. Most of the counterfeit parts are well enough done because the people making the counterfeit parts don't want to go to jail. They just want to make money. So, yay capitalism, I guess? I don't know. Okay.
So actually, this is very interesting. Now I understand better because I met the senior vice president of Airbus in charge of security, and I. He immediately talked to me about blockchain in that context because a lot of airplanes are leased. So what happens, the companies which lease airplanes, when they return, a lot of stuff is banged and bashed and broken, and it was not like before, but because there is so many different parts, the companies which return the airplane, they hide it, and then they release it to some other company, and then it crashes. So they want to use blockchain basically for each component to authorize another component. So all the pieces of the airplane are on the blockchain, and so you cannot replace one without making it obvious. So it's just like very simple IoT certification, right? So it's actually very legitimate. It's a good problem.
Yeah, and actually there's some like really hilarious ones with the aircraft leasing where the Canadian government loaned a bunch of money to some people who then like took the airplane and just didn't give it back. And like there's some interesting things there. The Canadian government makes some really high quality investment choices. Yeah.
Interesting. So maybe I'll ask one more question and then we'll open the So one topic which is really interesting to me, kind of which connects all these things, is eventual consistency. So I've seen these ideas from actual distributed systems community, right? Because they have to take all of this stuff. So there is more and more of it. So the onus is on them to basically process faster, but still maintain transactional consistency, financial consistency. So suddenly, you have to have more and more data, and then IoT will start produce billions of more data points. And the kind of expectation right now is like, okay, so put in a giant cluster, count it all, and it so should add to zero, right? Basically, there is a notion which we inherit from Oracle and kind of financial accounting that everything should add up, and so it's harder and harder to do. And so if like we're humans, we do not insist on everybody agreeing, and we basically each of us has local consistency, right? We kind of expect to be paid and fed and kind of have a house, but we don't kind of it's like not everybody believes this. So we have homeless people because a lot of people it doesn't propagate far, right? So humans basically, and we have different cultures and so forth. So we have agreements, we have consensus which is inherently local. So we're kind of trying to get global planetary agreement on like global warming, and still we do not get it, right? So there are very few things which, like, we don't have to have nuclear war, probably, right? So humans are not actually made for eventual or global consistency. So, but somehow, as computer scientists, we think it's cool, and like we're trying hard to do it, and we have spanner, right? Like, let's synchronize everything atomically, and then suddenly we have magical consistency everywhere. So, so I think Alluxio is an interesting niche. You guys put it all in memory, so you can do that. Right, but memory is transient, and so with the edge, and we have a different scenario. Things go offline, and they don't come back for a long time, and then suddenly they pop up and say, "Okay, I'm here. I'm not dead. Take me back." And no, you're dead. Stay dead. Right. So the question is, so I think there are these interesting trends that more and more IoT devices will connect to this global Internet of Things, and they will have to agree on different things, right? Like they need to be paid or they need to be tracked. If they're cars are all going to be IoT devices. So cars, like what Whitey described, there is a Mobi Alliance which hopes that, let's say you need to make a left turn and you're a stressed out mom and you have kids screaming in your back seat, and so you suddenly make a left turn and you're dead. Like this shouldn't really happen in a good society. So the left turn car will negotiate. It will pay tiny Constellation tokens to the cars in front of it, right? And they will slow down, right? Like basically, what is it worth to them to rush and kill the mom instead of just waiting, right? So basically, like a lot of things we're currently stressing out, the theory is that it will go away because, for instance, cars will pay each other to accelerate and decelerate, and there will be local consensus. Maybe it will be flocking behavior. It will propagate across the whole highway, I-95, and suddenly it all will flow, right? So, but the question is, so I'm kind of, I'm pointing to everybody in their own sense, right? Because I think it affects everybody. Do we, and even Spark? So we kind of assume it's all there. We kind of don't imagine so there is an RDD. So it's kind of some failure mode is there. So something failed, but we kind of think it's a bad thing. Let's restore it. Let's replay everything from the beginning. Let's get back where we were. So should we really be doing this? Should we just agree that stuff is gonna disappear and it's okay? So not a number is a good thing, right? Like, should we think of this probabilistic world where stuff is not going to be eventually consistent? It may be consistent to some degree, right? And there are different degrees of goodness. Like, you're not dead, you have food, you enjoy yourselves. Like, there is this pyramid of needs. So should we just establish everything, or should we, relinquish some of this consistency?
Well, that is deep. I guess I'll try to maybe just highlight it from a different angle. So look, I think we've reached, the level of complexity in just like everything that we do, the industrial processes, the social processes, like everything that we do, the level of complexity is now such that it is very difficult for us to actually track things through supply chain, right? And again, I use this term, very sort of in a very flexible manner, right? It's like supply chain management applies to just about anything, right? So I think we will see a lot of kind of like, going back to basically trying to manage just the local behavior, right? And then just hope that the emergent behavior will be not something that would end up us destroying, Earth or whatever else, right? But I think we're just not capable of managing the global sort of state of things. Like, we've just reached that level of complexity. And maybe we will, at some point, start being able to do that. But I think the best option for now is sort of try to orchestrate the local behavior and hope, for the best.
So what you described with the car makes me think of like a really depressing libertarian dystopian future. And like, oh God, I don't want to build that. If we build that, we're bad people. Please no.
Blockchain?
Hey, I think we're all just trying to have fun out there and see what comes out. There's lots of stuff you could do, and I think we're gonna try a lot, and hopefully some of them work out. We'll roll with it. Cool. I don't know. Have some fun. All right.
So the world is always complex. It's always simple as well, and it's so from our perspective, probably you want to look at it from a simpler way. So there are lots of data that consistency is really hard, and people need those data to be consistent. For example, like your banking data, and it's transactional, and you need to be consistent. If it's not consistent, you always hope for a way not consistent better for you as a client of the bank. Of course, it's rarely happen. If it happens, it corrects them, right? So that's one side of the world. And the other side of the world is that if you look at the data itself, like majority of the data today, more than 95%, conservatively speaking, or even 99%, they are still like immutable data. And that type of data is growing tremendously along the way. And those data are video data, audio data, like media data, right? And machine logs, all those type of data. For those type of data, like because it's immutable, and in the end of the day, from the consistency requirement angle, just require much less work. So if that is the case, I mean, it is the case, and then from the system designer angle, like we always try to leverage that and use it as much as possible and make your system as simple as possible. And that's probably that's echo to Roman's like point, like in the sense of it's different. You want to what did you say? Like
Yeah,
localize it, right? So you always want to try to solve a localized issue, not localize it. You categorize the problems, and for this type of problem, yes, I mean, so use Alluxio, use ECS, use this and that. It solves already. And for the other part, like global consistency, if you want it, pay the cost, and brilliant people will make it happen. So that's how we see it.
So market, let the market decide, basically.
Yeah, exactly.
Oh, I forgot to mention, I just wanted to, that we also rely heavily on eventual consistency, and it's, kind of core to what we do as well.
This, like, in terms of time, how long is eventual?
Well, so we don't do things in terms of time. We do them in terms of, we have this finality window that we call a snapshot, and just up until sort of the point where we've gathered enough data to form one, we try to form the most optimal one that we can. Yeah, and it's all really based around our reputation system and sort of how we like self-organize. It's cool.
Cool. Do folks have questions? So when you think of questions, I'll ask one more question then. What is the currently most exciting technical problem you're personally focused on?
Okay. Fuck. Oh. My boss told me to swear less. So I think one of the things that I'm most interested in a technical problem is right now Spark does a really suboptimal job, one could say politely, of handling scale-down situations or loss of nodes and trying to make that less of a bad experience. We do a pretty good job if you occasionally lose nodes, but there's this thing where you might frequently be losing nodes sort of very consistently, and then just always recomputing on loss is no longer going to be optimal. And there's a lot of interesting things that we can do because often we'll actually have some idea that you're going to lose the node soon, and we could do smarter things there. And I think that's a fun problem to solve because it lets me screw around with a bunch of Scala code and hang out with the Kubernetes people who have nicer stickers. I don't know.
Cool.
So I guess what I'm mostly sort of preoccupied these days is it's not even a problem. It's sort of this, kind of like fundamental realization that if you look into the more traditional data center cloud, it's actually got really boring, right? It's like everything is kind of like not really cool anymore. Like, the servers don't really get to be cool. Like, we've sort of solved most of the things. It's like the data center architecture is sort of settled. Like the computing in a data center really stopped being cool. Like it used to be cool. I mean, like some time ago, but it's not anymore. And I think, that's by the way why, companies like HP are struggling and, almost all, everybody's buying, Huawei servers or something. But I think, with the edge, we actually have this really nice chance of essentially making computing cool again, in the same way that sort of like it got to be cool again back in the 80s, right? Sun Microsystems was actually founded on this principle. It's like, let's make computing cool again. So I'm actually thinking about how we can just basically Edge gives us this possibility of getting rid of, at least some amount of legacy, right? We no longer have to think about, some of the issues that, make data center computing not cool. And how can we use that chance, because that's once in a lifetime chance, right? To not screw it up. And actually come up with an architecture that would make computing cool again. And I really mean the end-to-end architecture. So that's why, for example, I'm so excited about RISC-V, because I think RISC-V has a chance of being to the edge what ARM has become to mobile computing, right? And with RISC-V and companies like SiFi, we actually do have that final chance. It's like it feels like being back at Sun again, right? We can actually design everything from the ground up. Like even the hardware is investable again. Like, try investing in CPU design, 5-10 years ago, like, you would be left out of the room. But like, with all of these emergent trends on the edge and, some of the other stuff, like, even the hardware is investable again. So let's use that chance to build a really cool system, from the hardware all the way up, because we are going to get stuck with it for the next 10, 15 years. So we better use this chance,
So there are many cool stuff, and there are many interesting stuff. I like blockchain, like AI, edge computing, all the type of cool technologies. But personally, I spend most of my time. Of course, I'm from Luxio. I'm super excited about the thing we're doing at Luxio itself, in the sense of the way we see the world is about the data. It is about the data in the end of the day. AI is an application of the data. Like analytics is the application of data. Like IoT, you generate lots of data. You need to leverage the data. You cannot make it wrong. Like autonomous driving is a lot of data in the end of the day. So then in that world, would it be better, would be very interesting or make the developer's life much easier that if you have a system that you can just put the data in, don't worry about it anymore, and later on you want to retrieve the data back, and that system will guarantee you you can make it happen, and you do not need to worry about the details. And it's like when you are using an iPad or when you're using a Mac. Why do you need to worry what CPU you are using or memory you are using? You do not need to care. You just need to make sure you're sending an email is sent, your experience is nice, and when you are watching a video on your laptop, it's smooth. Hopefully it's 4K as well. That's the thing in the end of the day, in the data world, say, if we can achieve that state, that'd be beautiful. And that's the thing we're working on, and we hope we'll realize it one day. So that's what I'm personally spending time on.
Cool. Yeah, I'm gonna break the mold actually, and oddly enough, keep it crypto. I've been tasked, or I'm doing the oddest thing I never really thought I'd ever do, which I'm making something called tokenomics. So I'm tying together some kind of how would I put it? Like a model that will actually govern sort of the way in which distribution will flow through my network as it kind of kicks off. And it was something that had ended up being oddly connected to how I built this thing. So it was kind of interesting. I ended up having to solve this well, not really a math problem, but at least make some plots. Yeah.
Thank you. Do we have any questions? If not, then I will say this is the time. This is the time, right? So it's been a long, productive day. Let's thank all the panelists.
Thank you so much.
And please do not forget the CFP for Scaled by the Bay 2019 opens May 1st. And we basically get, in the month of May, already 3 times more talks than we can fit, so please be quick with your best talk. So May 1st, mark your calendar, submit your best talk, get into the program, and we'll meet you back here on Twitter, November 2019. Thanks a lot.